Welcome everyone, this is Miss Scott. Today we're going to cover section 2.6, prove statements and about segments and angles, and we're going to learn how to write a geometric proof. This is probably one of the most challenging yet rewarding things you're going to do in geometry is write proofs. And you may have heard horror stories from previous classes, but really it's not as scary as it seems, and it's something that you just get better at over time. So in the last lesson we talked about the reflexive, symmetric, and transitive properties. Well, it turns out these properties also work when we talk about segments. If you have a segment AB, well, the reflexive property tells you that AB is congruent to itself. Pretty straightforward. And again, the symmetric property, if you have two segments, let's say segment AB is congruent to segment CD, and remember that symmetric property lets you flip-flop. You can say segment CD is congruent to segment AB. And then the transitive property also works for segments. So say segment AB is congruent to some segment CD, and segment CD is congruent to a third segment, segment EF. And then remember, we can cut out the middleman and we can say segment AB is congruent to segment EF. We might have actually had that same exact property in section 2.5. But hey, guess what? These three properties also work for angles. So again, if we have some angle, say angle 1, well, then angle 1 is congruent to itself. And likewise, if you've got two angles, say we have angle 1 is congruent to angle 2, and you can flip-flop and say angle 2 is congruent to angle 1. And lastly, the transitive property, let's start with if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, and you can cut out the middleman and say angle 1 is congruent to angle 3. Alright, so we're going to use those properties, just do a little practice with identifying them in examples 1 through 3. So example 1 tells us if angle RST is congruent to angle MNP, then angle MNP is congruent to angle RST. Looks like they just flipped the order, and remember, that's the symmetric property. Alright, let's see what they did in number 2. If segment XY equals segment AB, and segment XY equals segment GH, then AB equals GH. I know it's a little bit out of order, but we can actually rewrite this first part as AB is equal to XY, so we can flip-flop that. And then they're just saying this is equal to this since they're both equal to XY. Well, that is that transitive property that we talked about. And lastly, segment EF is equal to segment EF. That's that reflexive property. Okay, so there's just kind of a quick little use of those three properties. We're going to dive into proof writing right now, so here we go. We actually had this example in section 2.5, but now we're going to write a formal proof to prove that segment AC is congruent to segment BD. So please go ahead and add those symbols onto the statement. Alright, so let's start. You always start with what you know. So if we look in this picture here, they tell us that AB is congruent to CD. So segment AB is congruent to segment CD with those little tick marks. You're always going to start with something that's given. So your first reason for any proof will be given. Now, what can we say? Well, we can say that the lengths are the same. So AB is equal to CD. And this may be something new, but this is actually the definition of congruent segments. If segments are congruent, then their lengths are equal. All right, now what I'm going to do is, we did this actually in the previous lesson, so check out that last video if you forgot. Since those two segments share that part in the middle, the BC, let's add that to both sides using that addition property of equality. All right, well, AB plus BC is simply segment AC. So the length of AC equals CD plus BC is just the length of BD. And that's the segment addition postulate. If you're saying that two segments added up equal the whole segment, that's just segment addition postulate from chapter 1. And lastly, we're trying to prove this, that AC is congruent to segment BD. Well, if their lengths are the same, their segments are congruent. Again, that's the definition of congruent segments. All right, so you just wrote your first proof. Go ahead and give yourself a round of applause. Okay, the next two proofs I provided a word bank for you. So if you'd like to try these, go ahead and pause the video and see if you can figure out where these things go. There is a missing piece here that I need to write in. The measure of angle 1 is equal to 180 minus the measure of angle 2. All right, so now we've got all the things we need in the word bank, and you do need to cross out the subtraction property of equality we will not use. All right, so we are given that angle 1 and 2 here are a linear pair, and we're going to try to prove that the measure of angle 1 is 180 minus the measure of angle 2. Well, our first reason is the given, so all we have to do is copy the given. Angle 1 and angle 2 are a linear pair. So let's go ahead and cross that out in our word bank. All right, so our next reason says the angles in a linear pair are supplementary angles. Well, I think in our word bank, the only thing that really goes with that is the first thing there. Angle 1 and angle 2 are supplementary. And we know that a linear pair means that they're supplementary adjacent angles. So yeah, that makes sense. All right, so we use the first thing here, and then they're saying the measure of angle 1 plus the measure of angle 2 is 180 degrees. Well, that's just the definition of supplementary. Supplementary, and I'm going to abbreviate this with angles, just using the symbol. And lastly, what we're trying to prove is the measure of angle 1 is equal to 180 minus the measure of angle 2. So they kind of skipped this step. The reason is subtraction. What they did here was subtract the measure of angle 2 from both sides to get the measure of angle 1 by itself. So they're just using that subtraction property of equality. All right. One last proof here. This is kind of a longer one, so let's get started. All right. So we've got a word bank again. That's going to help us out a little bit here. We are given at 2 times this measure of angle ABC. So if you double that, you get the measure of angle ABD, the whole thing. All right, and we are going to try to prove that angle ABC is congruent to angle CBD. So that's what we're going to try to get to. All right, so let's start with what we know. We know that 2 times the measure of angle ABC is equal to the measure of angle ABD. Your first reason will always be given. So we used the given statement, and the given is the reason. All right, well, what does 2 times something mean? Like if you have 2 times 3 equals 6, that's the same as 3 plus 3 equals 6. You're just repeating the 3 twice. So we're going to use that same idea, but now say the measure of angle ABC plus the measure of angle ABC is equal to the measure of angle ABD. So that was this first reason here. And that's actually just the definition of multiplication. Okay, multiplication is just repeated addition. All right, let's see what we can do next here. If I look at this, I'm gonna focus here on the measure of angle ABD. So this, let's go back up to this picture. That angle is created by 2 angles, right? It's created by this angle ABC here on the right. So the measure of angle ABC, and then it also is this angle on the left, angle CBD. All right, do you remember why we can say that those 2 smaller angles added up make the whole angle? All right, well, we use this reason. Is it the subtraction property, the transitive property, definition of congruent angles? That's actually this one right here, the angle addition postulate. Remember, 2 smaller angles added up equal the whole angle. All right. Now let's see what we can do. Well, take a look here. We've got this and this both on that side. So think of that as the middleman. Then what we'll do is we'll say this is equal to this. Since they're both equal to ABD, they have to be equal to each other. So that's this right here will be our 4th statement. Measure of angle ABC plus the measure of angle ABC is equal to the measure of angle ABC plus the measure of angle CBD. And that is the transitive property. Remember, if you cut out the middleman, that's that transitive property of equality. All right, notice both of these have ABC. So I'm going to subtract the measure of angle ABC and subtract the measure of angle ABC so that these cancel. And I'm going to end up with the measure of angle ABC is equal to the measure of angle CBD. And that's the subtraction property of equality. All right. And lastly, if the measures are equal, the angle ABC must be congruent to angle CBD. That's just the definition of congruent angles. So we used that, use that, use that, use that, and that, and that. So that was a little bit tough, but we survived. If you guys have any questions on this proof writing, please don't hesitate to ask, and we'll see you guys next time.